So we're doing discontinuity, and it's really pretty easy. There is this formal definition. The informal definition is if you have to lift your pencil to draw the function, then it's discontinuous. This is the formal definition. The function is continuous at the point A if f at a exists. Obviously, if it doesn't exist, then you've got a problem. It's going to be discontinuous, and you'll get a hole. The limit has to exist. So that means coming at this point from the left and right has to be the same. So the limit has to exist. So you can't have these jump discontinuities. This says you can't have a hole. And this last one says the limit as x approaches a, the limit has to be equal to the function at a. And so you can't have crazy things where the function has a hole and then it has an actual value, but the value is not equal to the left and right limits. So it's a very theoretical construct, this whole thing where there's, oh yeah, there's a value up here, but it's not the same as a limit. This one fails the last test. This one is a hole. This one catches all the jump discontinuities or infinite discontinuities or restrictions on the domain. All right, I don't think that's I think that's pretty easy, actually. So with no further ado, let's jump right into a question. So let's do this. Let's make, I'm spelling x cubed wrong. How do you spell x cubed wrong? X cubed minus 8 over x minus 2, continuous. Okay, so yeah, let's call this f at x. There we go. Okay, so make that continuous, and we are going to make it continuous because, look, it has a hole. Because for this one, x just can't be equal to positive 2, or we divide by 0. Good. However, this is an example of a hole, because this we recognize right away as being a difference of cubes. So difference of cubes it is definitely necessary. Okay. So we're going to break this. We're going to factor this because it winds up being a hole. I designed it that way. So basically, we know that x minus 2 is one of the factors. That's the way a difference of cubes works. And we also know that we have to multiply it by some quadratic in order to get x cubed minus 8. So x times whatever it is has to result in an x cubed. So that must be an x squared. And then this means that that is going to be minus 2x squared. Okay, there are no x squared terms in x cubed minus 8, so we have to add 2x squared to make it all work. So that means that this is a 2x, and that means that this is a minus 4x, but there are no x terms, so that means we have to get rid of that 4x, and so that means that this is plus 4, and that's minus 8. Okay, so we can factor this x cubed minus 8 into x minus 2 and x squared plus 2x plus 4 all over x minus 2, and x can't be equal to negative 2. So there we go. We've got that. Oh, positive 2. So we have that discontinuity. Now, if you've memorized the difference of cubes formula, good for you. If you're like me, you can never remember it quite right, and so I would factor it. We just used the box method here. If you're not familiar with it, I can teach you a lesson on it if you like, but it's just a nice way of factoring really big polynomials. Okay, so if we looked at this, we could actually simplify this function, and we could represent it differently. We can say that, yes, this is just x squared plus 2x plus 4, but x can't be equal to 2. we're going to turn it into a piecewise function. We're going to let f at x be f at x is going to be equal to x squared plus 2x plus 4, as long as x is not equal to 2. And then we're going to figure out what f at x is when x is equal to 2 in order to fill in that jump discontinuity. And we'll do that by putting this expression, putting 2 into this expression.
I thought you weren't allowed to do that.
We're not allowed to do that normally, but we are allowed to do it because we're going to fix this broken function. We're going to heal it. So this function is x squared plus 2x plus 4 whenever x is any number except for 2. And it's 12 when x is equal to 2. And so we've healed the function. We've filled in that little hole or removable discontinuity just by defining the function as being 12 when x is equal to 2. So we fixed that function.
Do you not just define it to be the first thing? Remove the x is not equal to 2?
So the question here is, couldn't we just say it's x squared plus 2x plus 4? And the answer is, I guess you could. But that would be kind of curmudgeon-y. So let's not do that. Okay, here's the second thing. Oh my goodness, I might get this wrong. So this is a function, and it is cx squared plus 2x as long as x is less than or equal to 6. And it is x cubed minus cx as long as x is greater than 6. And the problem is find c, so the function is continuous. Okay, so if we pick the wrong c here when x is equal to 6, this function might develop a jump discontinuity. So we need to fix c so that the two are going to meet when x is equal to 6. And so to be continuous at x is equal to 6, c x squared plus 2x has to be equal to x cubed minus cx when x is equal to 6. And so we're going to put in a 6. So c times 36 plus 12 is equal to, what is 6 cubed? Anybody know? 36 is, I think it's 260. 216. There we go. Minus 6c. Okay, I'm going to turn this into a 36c because I think it's more beautiful. There we go. Did I do everything right? Is that all there is to it? I think so. All right. So this actually becomes, I'm going to move the c's over onto this side. 42c is equal to 204. And so c is equal to 204 over 42, which is 102 over 21. And does 3 go? Oh my goodness, 3 goes into both of these. And so 3 goes into this 34 times. And 3 goes into that 7 times. And then we're done. Okay. So find c. c is equal to 34 over 7. And these two functions are going to magically meet up when x is equal to 6. And we'll have no jump discontinuities with this function. Anyways, there's continuity. It's actually pretty simple. The most complicated thing is making the piecewise functions meet up. That's it.